Hi students, this video we are going to see about the epicycloid. The epicycloid is how to construct the epicycloid. So first we can see about the question. Draw an epicycloid of circle of diameter 50 mm which rolls outside a circle of diameter 200 mm for one revolution. Also draw a tangent normal to the epicycloid at a point 135 mm from the center of the directing circle. So this is the question. So before entering to the question, so we can make the difference. First to clarify the difference. What is the difference between cycloid and epicycloid? Suppose here there is a word called directing circle. Suppose this is the center, means this circle will be, half of the circle will be drawn as the directing, can be considered as the directing circle. So here this is your rolling circle. This will be rolled in this way. This is clockwise direction, it will be rolling. Anti-clockwise means it will be rolling in this way. The question itself, it will be clearly given like that. Rolls over, rolls outside, the word will be very clear. Okay, so this is the thing. So first the question is given for 50 mm diameter. 50 mm diameter means the radius will be 2.5. So as we know, I am going to take the 2.5 mm of radius. First I will draw the center point. So by here I am just going to draw the circle like this. Look at here how I am holding this compass. Now I am going to draw that, find out the directing circle. For the directing circle I am just going to draw by an inclined line. So look at here, through this diameter it will cross at here 5. So the directing circle radius diameter is given as 200 mm. So the radius will be 100 mm. So now this is, we can take the total value will be 15 mm. 15 mm means 100 mm and then the 50 mm radius diameter. So here the 100 will be there and above that the circle will be there. So this is the our diagram. So this will be the capital O and here this will be the C, center point. Now we can draw the perpendicular lines. Here we can divide this into equal parts, 8 equal parts. The 8 equal parts may be here 1, 45 and this is 45 and this is 45. So now I am going to draw like this, and again another one, like this. I just divided this into 8 equal parts. So now for a small calculation we need to find out the theta. Theta is equal to 360 degree multiplied by smaller d divided by capital D. What is that smaller d? This will be the considered as smaller d and this will be considered the total plus another one length will be considered as capital D. So 360 into 50 divided by 200. So what will be the value now? So here the value is this is 1 and this is 4. So this divided by this one means it is 90. The value will be 90 degree. So by in your protractor you can take the 90 degree here. So this is 90 degree. Here you can take the same length. What is the same length? 100 plus or 50. So totally it is 100, 150. So totally the value is 150. I have taken like this. So now here this angle has to be divided into 8 equal parts, as what we have divided here. Here also it should be divided into 8 equal parts. What is that? 90 divided by 8. So 80 and 8 point. So this is 10 and again 11, and then remaining 2 will be there. So here it is 2 and again 4 will be there. So this is 25. 11.25 will be the each degree. So here we need to make the difference between for that 11.25. This is 11.25 approximately. I can make it here, and plus 1 again 90 has to divide by 4 equal means this will be 45, and here 11.2, this is 11.25, and again here 22.5, 22, here it is 5, and here also 72.5, and remaining here half the we have to make it. So that is 1 2, this is, and here also 1 11 11. So this is the 11 equal parts. So sorry, 8 equal parts we have made it. So now we can gently draw all the circles here. What are the circles we have to make it? It is first circle I am going to just draw like this, and the second circle from here, this will be the directing points wherever we got the point. Then from C also we need to make it. Look at here, in the previous cycloid, for these 3 points at the center horizontal line, for the 3 points we have drawn a single horizontal line, but here it is not like that. Here we have drawn 2 lines. The compass is too small, so I have to adjust for a large. Actually this compass I purchased from the geometry box one, so that the size will be very small. If we get the instrument box means it will be perfect one, and also you can extend it. Anyhow I manage now. Okay, we got it. So this is the length. So now we can extend it. How we are going to extend it is, we can come from this side. I drawn it, and next we can draw like this. Again the same. Again next. So that we have divided all the thing into 8 equal parts. So here one thing is remaining. We need to give the name. Already we know here we need to give, we will give the name as 1, this point is 2, and this point is 3, 4, 5, 6, 7 and again 8. This will be 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash, 7 dash, 8 dash, and this is C1. Look at here, this point, not the above point. This point is C2 and this point is C3. This point is C4 and this one is C5. This is C6. This is C7 and this is C8. Actually, without the name, the diagram is incomplete. So, we need to give the name perfectly. Now, the main part. So, here we can measure the radius, that is 25 mm, already we know it, and what we did the previous one, like the same way here also we have to make it. This is first arc is here, we made it, and the second arc here, just listen where I am going to fix it. C1 and the first line locus. C2, here the locus is different, second line locus, that is the above line, not the center line locus, above line, that is the C2 one. Then C3 is here and C4 is here, then C5, here it is, then C6 is here, above line, not the center line. C7 will be here and the C8 is here. Okay. Now we need to draw the profile. I already told how to hold the pencil. Hold your pencil like this. Now join these two. Next line is here and another next line coming to here. Actually, this will be in little large distance, so you have to manage the freehand line by this. Okay, and next, then, so just finished. Okay, so now I am draw it by the dark line. For our video purpose, for clear visible, I am just drawing it, continuing by sketch pen. That's all, we finished it. Now we can also give the name here. How to give the names are, so this is P1 and this is P2 and this is P3 and this is P4 and this is P5 and this is P6 and this is P7 and this is P8. So that's all we have given the names. And in your question it is told from the directing circle center. Which one is directing circle center? This is the directing circle center. So from here we need to take 135 mm. What is that 135? Somewhat they have given the dimension, so we need to take the measurement on it. So for 135 I am just measuring it for a length. So this is 135. For this 135 I am just keeping this as a center. In your compass, take 135 mm, either this side or this side, any one of the side you can take it, either this side or this side. This side I am going to take it. So here I made arc, so it is here. This is the point. Point is called as P. Now we know the dimension here, radius. This radius is 2.5 mm, 25 mm. For this 25 mm, I am just going to make an arc on the center line, not any other way. On the center line I am going to make it, because there are two lines, the confusion will be there. So the center line. Now I am just connecting it, these two. Okay, here it will be crossed. So this point will be called as N, and now you can join these two and extend it. This is NM, that is normal. Now we can draw the tangent for it. As usual, we know how to draw this. Draw a perpendicular line Now we can finish it. Okay. Also you can darken this by sketch. For our video purpose I am doing this. So here it is given like this, and this is your simple one, how the easy method to draw this. And here the dimensions are very important. How to make the dimensions are, it is here, this is the basic one, and next step will be here, another step will be here. I am just connecting all the three. So this is one step, and here another one. So this is pi 50, and this length is, this is radius, so or 100 or 100. This calculation is also necessary, we need to do it. Another one, we can write the sentence, all dimensions are in millimeter, and here we can make it like this. This is EpiCycloid. All dimensions are in mm. So this is your method of drawing epicycloid for the given question. Okay, thank you.